Hi, my name is Alyssa, and I'm a math and science tutor. Today, I'm going to be solving a problem involving angular and linear velocity of a point on a planet. Let's get started. The arc from point A to the North Pole of a planet subtends a central angle of 40 degrees, as shown in the figure below. The radius of the planet is 3,921 miles. A point on the surface of the planet, except at the poles, makes one revolution about the axis of the planet in 26 hours. What are the angular and linear velocities for point A with respect to its rotation around the axis of the planet? All right, for problems like these, I always like to take the information that I'm given and write it in one place. So we know that we have a theta of 40 degrees, we have a planetary radius of 3,921 miles, and we know that a point, except at the poles, makes one revolution in 26 hours. And now let's go ahead and write the equations that we'll be using for this problem. The linear velocity is equal to the angular velocity times the radius, and the angular velocity is equal to an angle over time. Let's review what our question asks us. We are asked what are the angular and linear velocities for point A with respect to its rotation around the axis of the planet. So that means we are looking for this right here. We're looking for its rotation around the planet, and we need to calculate the angular and linear velocities based on that rotation. So let's go ahead and figure out what the angular velocity is first. And it turns out that we're given that information in the question. We just have to do some simplifying. Because we know 1 point makes 1 revolution, or 2 pi radians, which is our angle, over 26 hours. And that's our time. We have an angle over time. And we can simplify this to just pi over 13 radians per hour. So that's our angular velocity. All right, now let's solve with the linear velocity. Now that we have our angular velocity, we can plug that into our equation, but we're still looking for the radius. We're given a planetary radius, but that is not going to be the same as the radius that we need to plug into this equation. And that's because we're looking for the radius of this circle, this rotation here. So this is the radius that we need, and we're going to have to solve for that. So let's do that now. It's important to note that anytime that you have a radius in a circle, it's the same length anywhere in the circle. So this radius right here is going to be the same length as this radius here. And you'll notice now that I've outlined a right triangle. And we have enough information now to solve for the radius that we need. This is the same as this. So the hypotenuse of our triangle, we know, is 3,921 miles. And we have an angle, so we can use sine. We have information opposite of our angle, and we have the hypotenuse. So let's plug that in. We have sine of 40 degrees is equal to our opposite information, or the radius that we're trying to find, over the hypotenuse. We need to solve for x. To do that, we can multiply this side by 3,921, and we cancel. And then we need to multiply this side by 3,921. Plug this part into your calculator, and when you do that, you should get 2,520.4. And this is our radius. This is miles per radian. When I write the units for my radius, I always like to include the length units on top and radians on the bottom. Because as you're solving these problems, you'll notice that the units cancel very nicely later. All right, so now we have enough information. We have our radius and we have our angular velocity to use this problem to solve for what we're looking for. So the angular velocity is what we're looking for, is equal to our pi over 13 radians per hour times our radius of 2520.4 miles per radian. And as you can see, these units will cancel and we'll be left with miles per hour. So let's go ahead and do this calculation. Plug pi over 13 times 2520.4 into your calculator, and you'll get 609.1 miles per hour. And so we've solved for both our angular velocity and our linear velocity. I hope this video helped you. If you'd like to see me answer more common trigonometry homework problems, please make sure to like this video and subscribe to my channel. Thanks so much for watching.